find extreme value of a function f of x comma y, which is equal to x cube plus y cube minus 3x minus 12y plus 20. Here what's the first step? We have to take the given function f of x comma y, which is equal to x cube plus y cube minus 3x minus 12y plus 20. Here in the problem they have mentioned we have to find the extreme value of the function, that means maximum and minimum value for the function. After writing the function f of x comma y, in the next step we have to find del f by del x and del f by del y. Here del f by del x is nothing but the partial derivative of f with respect to x. That means we have to differentiate this equation partially with respect to x, means we have to treat y value as constant. Here differentiation of x cube is 3x square. Here this is differentiation of constant is 0. Here differentiation of minus 3x is minus 3. Here differentiation of constant is 0. Here also differentiation of constant is 0. Hence we get del f by del x value as 3x square minus 3. Similarly del f by del y, that means we have to treat x as constant and differentiate with respect to y. Here this value is 0 plus here differentiation of y cube is 3y square. Here this value is also equal to 0 minus 12 into differentiation of y is 1. Here this value becomes 0. Hence we get del f by del y value as 3y square minus 12. After finding del f by del x and del f by del y, we have to equate these two equations to 0 to find maxima and minima of a function. Del f by del x equal to 0 and del f by del y is equal to 0. Here del f by del x value is 3x square minus 3 is equal to 0. Del f by del y value is 3y square minus 12 equal to 0. Or we can take it as here 3x square minus 3 equal to 0. If we take 3 to the right hand side and 3 goes to the denominator, we get the value of x square as 1. Here 3 by 3 we get the value of x square as 1. Similarly, if we take 12 to the right hand side and 3 goes to the denominator, we get as 12 divided by 3. Hence we get y square value as 4. If we take this square to the right hand side, that becomes square root of 1. We get as x is equal to plus or minus 1. Similarly, y value is equal to plus or minus 2. Hence we get the point of intersection as here x value is plus or minus 1 and y value is plus or minus 2. Hence we get the point of x comma y as plus or minus 1 comma plus or minus 2. Hence we get the points as 1 comma 2, 1 comma minus 2, minus 1 comma 2, minus 1 comma minus 2. These are all the point of intersection obtained after equating del f by del x to 0 and del f by del y value as equal to 0. In next step we have to find ABC value. Here for that del f by del x value is 3x square minus 3. Del f by del y value is 3y square minus 12. Hence we get A value as, we know that A is fxx, that means del square f by del x square. Hence we have to differentiate this term, that is del f by del x, again with respect to x, we get the value of A. Here differentiation of 3x square is 6x. Minus here differentiation of constant is 0, hence we get A value as 6x. Similarly, B is fxy, that means del square f by del x del y. That is, we have to differentiate del f by del x, again with respect to y we get as del square f by del x into del y. Here in the del f by del x value no y term, hence we can take a B value as 0. Similarly, C value is fyy, that is del square f by del y square. Here del f by del y is this. Again we have to differentiate with respect to y, we get as del square f by del y square as a differentiation of 3y square is 6y. Here this value becomes 0, hence we get C value as 6y. After obtaining ABC value, next step we have to construct a table like this containing 6 rows. First we have to take the points, next A value, B value and C value. After finding ABC values, we have to find AC minus B square value also. Last is conclusion. If we construct this table, we can easily find the value of maximum value, minimum value, or it is a saddle point or not. Here in the points, we can take the points of intersection, that is minus 1 comma minus 2, minus 1 comma 2, 1 comma minus 2, 1 comma 2. We can exchange the columns also. Next we have to find ABC value. For that, substitute x value as minus 1 and y value as minus 2. Here A is 6x. In the place of x we can substitute as minus 1, means 6 into minus 1 is minus 6. Hence we get A value as minus 6, which is less than 0. Here negative value, hence we can take it as less than 0. Similarly, B is, here B value is 0 itself, hence we can take B value as 0. Similarly, C is 6y, that means you have to substitute y value as minus 2 here. That is 6 into minus 2 is minus 12. After obtaining ABC values, next we have to find AC minus B square value and find AC minus B square value is greater than 0 or less than 0. Here A into C minus B square. Here A is minus 6 and C is minus 12. Hence we get 6 into 12 is 72 minus here b is 0. Hence we can take it as AC minus b square value is 72 which is greater than 0. We already know 72 is greater than 0. In the similar way we have to find the values for minus 1 comma 2, 1 comma minus 2, 1 comma 2. Here in next step we have to substitute x value as minus 1, y value as 2. Hence we get a value as 6 into x is minus 1. Hence we get the value as minus 6 which is less than 0. B value is here no x and y values, hence we can take b value as 0 itself. And c is 6y. That means you have to substitute in the place of y as 2. Hence we get 6 into 2 is 12. Next we have to find AC minus b square. Here a is minus 6, c is 12. Hence we get the value as minus 72. Here no b value. Hence we get minus 72 which is less than 0. In the similar way we have to substitute x value as 1 and y value as minus 2. We get a value as 6, b value as 0, c value is minus 12 and AC minus b square value as here 6 into minus 12 is minus 72 which is less than 0. In similar way we have to substitute x value as 1 and y value as 2 here. Here a is 6 into 1 is 6 which is greater than 0, b is 0 and c is here 6 into 2 is 12. Next we have to find AC minus b square, that is 6 into 12 is 72 which is greater than 0. In last step we have to find the extreme value for the function. We already discussed the working procedure to find extreme value. That means here AC minus b square value is 72 which is greater than 0. Again a value is less than 0. Hence we can conclude that the given function has a maximum value at the point minus 1 comma minus 2. Similarly we have to find here AC minus b square value is minus 72 which is less than 0. And a value is minus 6 which is less than 0. Both are less than 0 means we can conclude that the function f of x comma y has a saddle point at the point minus 1 comma 2. Similarly here is for the point 1 comma minus 2 AC minus b square value is less than 0 and a value is greater than 0. Hence we can conclude that the given function has saddle point here also. Similarly for the last point 1 comma 2 here AC minus b square value is 72 which is greater than 0 and again a value is also greater than 0. Both are greater than 0 means we get minimum value for the function f of x comma y. This completes the problem. Here to solve this problem here to construct the table is very important. Here we know that AC minus b square is greater than 0 and a is less than 0 means we can conclude that the function is maximum. Here we have to note that if AC minus b square value is less than 0, we can conclude easily that it has a saddle point. Either a is less than 0 or greater than 0, it does not matter. If AC minus b square value is less than 0, directly we can conclude that the function has saddle point. This term we have to remember.